Hey everybody, we are doing notes again today. This is our third day of notes, so if you want to start organizing things by number, once we start in the book, everything will have a section number, but with this review chapter, we're just kind of making up our own numbers. So we are going to call this Chapter 1A, Day 3. Our main topics for today are fractions and exponents. All right, so first let's look into fractions. So again, just like last week, anything that you think is important, go ahead and write in a notebook. You definitely want to get all these examples in the notebook, but as far as this stuff at the beginning, some of you might already know this stuff and it won't be a super useful thing to write down. If you're not quite sure that you remember fractions, then go ahead and pause the video if you need more time. And write this stuff down so that you can come back and look through it when you need to as you're working through your homework. So the first thing, anytime you see simplifying, we are just reducing. So we're going to practice reducing fractions today. When you reduce fractions, you are dividing the numerator and the denominator by the largest common factor. So we will practice some of those in a minute. Typically in this chapter, this review chapter, we don't allow calculators. However, I'm not going to be watching you do any of this, so if a calculator happens to make its way into your hands, I will show you the buttons that will help you out, but I'd like you to try it without a calculator if you could, but if you're struggling or if you want to check your work before the answer keys are released, I'll show you how to do that as well. So we're also going to look at adding and subtracting fractions. When you add or subtract fractions, you want to first reduce the fraction, then you have to get common denominators, okay? That is not going to be the same thing when we are multiplying. So last week when we were talking about signed numbers, we said, you know, this is one house that has a different set of rules. This is another house that has a different, you know, an additional set of rules. Same thing when we're working with fractions. When you add or subtract, you have to have common denominators, and then you keep those denominators the same, okay? When you're multiplying, first you have to make them an improper fraction. You can take out any common factors. A lot of people call that cross-canceling. And then you just multiply straight across the top, straight across the bottom. You do not need common denominators over here, okay? So again, different set of rules. Do not mix and match your adding and subtracting with your multiplying rules, okay? And we are actually not going to look at dividing fractions today. That's a little bit even trickier topic. So just adding, subtracting, and multiplying for now. So like I said, it's kind of an interesting year because typically I don't allow these. However, I know that they're out there. So if you are going to use one, at least use it right. So here is the fraction button. This is what I wanted to point out to you. If you have, I know the pink version of this same calculator has the same button, but it looks like that. It's just a slash. And then I've also seen the button look like this. It's N/D, so numerator slash denominator. So any of those buttons, that is your fraction button. So let's say you wanted to type in like 2/5. You'd enter the 2, and then whichever button you have, and then the 5. Okay, but again, not necessary, but if you're going to use it right. Okay, so first example, we are going to simplify 16 over 24. So if you haven't taken any notes yet, now is where you need to start. These examples need to get in your notebook. Math is not a spectator sport. You can't just watch me do it and magically know what's going on. So go ahead and get those notebooks ready, and we will reduce this guy. So the first thing you want to do is find the largest factor that goes into both of these numbers. So what's a number that multiplies into 16 and 24? If you pick the biggest number, that's the easiest way to do it, okay? So when I first looked at this one, I was like, oh, it's going to be a 4. 4 will work, but it's not the largest one, so you have to reduce again. The largest one is actually 8. So I'm going to divide the top number by 8. I'm going to divide the bottom number by 8. And again, we did 8 instead of 4 or 2 because 8 is the largest one. All right, so you can divide the top by 8. We get a 2. Divide the 24 by 8. We get a 3. So 2/3 is this fraction reduced. If you need more time, pause the video. If you are ready to roll, let's go on to number 2. So here's our next one. Now, something like this, I'm kind of torn on how to show you how to do it. If you are dividing two numbers and don't really think about it as dividing. This is typically how we write division in algebra, but for today, just think of it as a fraction. So if you have a fraction and both the numerator and the denominator end in 0, you can actually just cross the zeros out. That's kind of the easiest way to do it. What we've done by crossing those zeros out, technically, we are dividing the numerator and the denominator both by 10. So it's a little bit of an easier trick. Again, anytime we have something like this, for some reason, my algebraic mind just says divide, but for today, let's think of these as fractions. So I will try to catch myself next time I want to say that. All right, if you need to write this one down, take a minute, pause. If not, let's continue. All right, so example 3. Now we are actually getting into a little bit more of the challenging ones. So the first 2 we just reduced or simplified, and this one we actually are going to subtract. So in order to subtract, you need common denominators. So when you get common denominators, you want to see what you can turn each denominator into, and they have to match. And the way we do that is through multiplication. So 3 and 5 both can turn into a 15. I can multiply both of them by a number to make a 15. So that's going to be the way I'm going to attack this problem. So if I want to turn a 3 into a 15, I need to multiply by 5. So I need to multiply the numerator and the denominator by 5. 5 times 1 is 5. Okay? Next, how would I turn a 5 into a 15? Well, I would multiply that by 3. Okay, so I need to multiply the numerator and the denominator by 3, and that gives me a 12. Once you have common denominators, you just focus on your numerators. So I actually need to do 5 minus 12. Well, 5 minus 12, from what I learned last week, is a -7. The denominator stays the same. Now, if you are one of those people that has that calculator, this would be a great time to say, that kind of looks, I'm not real confident. Let me type it in. So I'm going to type 1, ABC button, 3, subtract 4, ABC 5 equals. Now, it will do all that work for you. It gets the common denominator, it figures out the signs, and it does say -7/15. So I know that I've done this problem right. Again, I don't want you using the calculator, just typing it in and flying through all this material. I want you to do it by hand and just use the calculator as a tool to check your work. All right, example 4. Now, we are adding here. So what pops out at me is that second fraction can be reduced. However, I don't know if that's going to be super helpful. Let's reduce it, and then we'll just go with it. So both of those are even, so I can just go ahead and divide top and bottom by 2. So this guy stays the same. Back here, I can make it 4/7. Now, I said it wasn't going to be super helpful because I still don't have common denominators. So I can't really go right into the addition yet. I have to find a number that 6 and 7 both multiply into. So I think 42 is going to be our only option here. So let's go ahead and turn both denominators into a 42. So how do I turn a 6 into a 42? Well, I multiply it by 7. All right, so that gives me a 35/42. And how do I turn a 7 into a 42? Well, I multiply by 6. Okay, so that's going to give me a 24. Okay. Now I can go ahead and, let me get a new color, add the numerators, keep the denominators the same. So it's 59 over 42. Now, I do not want you to turn that into a mixed number. Improper fractions are just fine. Okay, you do not have to divide, you know, the 59 by the 42 and make it 1 and whatever. Just leave it. It's good. Improper is better than a mixed number in my book. All right, real quick, I'm going to check this with the calculator just to review how to do that again. So you'd hit 5, your ABC button, 6, plus, I'm going to go back to the original, 8, ABC 14. Now, my calculator is saying 1, and then it looks kind of like a U, 17/42. So now I am not presenting my answers as mixed numbers, so you can actually hit the second and then the ABC button again, and it'll make it an improper fraction for you, and it is 59 over 42. All right, if you need more time with that one, go ahead and pause. If not, I'm going to keep us going. Okay, here we are multiplying fractions. Now, this is one where you can cancel across your multiplication symbol. So any numerator can simplify with any denominator. So you can see right here, these are both divisible by 5. So I am going to cross them out. If I divide 55 by 5, I get 11. If I divide 5 by 5, I get a 1. Okay? Same thing going the other way. 8 and 24 are both divisible by 8, so you can cross them out and you get a 1 and a 3. Now, last week I learned about multiplying two negatives. A negative times a negative is a positive. So now I'm ready to multiply across the top. I have 1 times 11. 1 times 11 is 11. And 1 times 3, and my denominator is 3. All right, if you need more time, pause. If not, let's continue on. Here we are working with more fractions. We actually need to turn these into improper fractions first. So in order to do that, we need to multiply these two numbers, and then we need to add this guy. So 7 times 2, that's 14, and then plus 2 is 16. So 2 and 2/7 written as an improper fraction is 16/7. Okay, I'm still multiplying. I want to keep the negative. Same thing back here. I want to multiply these, then add this, and that's my new numerator. So 6 times 5, that's 30, plus 5 is 35. Okay, pause here if you need to. Go ahead and double check that math for me. And then we are going to start cross canceling on this one. So I see right away that 7 and 35 are both divisible by 7. So 7 goes into 7 one time, and it goes into 35 5 times. Okay, and these guys are both even, so I can divide them both by 2, and I get 8 and 3. All right, multiply across the top, and don't forget that negative. You might want to pop it over here with the 5 if you're going to lose track of it. But 8 times -5 is -40, and 1 times 3 is 3. Again, I do not want you to go mixed number at this step. Just leave it improper, and you're good to go. All right, let's keep moving. Okay. Next big topic for today is exponents. So what does raising a number to an exponent or a power really mean? The exponent tells you how many times to multiply the base by itself. So here is, I'm just going to get it all up there and then we'll discuss. here's where the exponents really get tricky. A lot of people understand the basics of exponents. I'm just going to write one up here. So here's the base 2, here's the exponent 3. So I am going to multiply 2 by itself 3 times. Everyone's pretty good with that by the time they get to my class, okay? So 2 times 2, that's 4, times another 2, that's 8. Boom. When it gets tricky is when we introduce the negatives, like we talked about last week. So that's why when we learned multiplying with signed numbers, we talked about if you have an even number of negatives or if you have an odd number of negatives. Here's why that's important. If you have an even number of negatives, and that negative is in parentheses to that exponent, your answer is going to be positive, okay? So right here, if I was going to write this guy out, this is actually like a -3 times a -3. A negative times a negative gives me a positive. Back here, I still have the 3 to the second power, but the negative is not going to the second power, okay? If I was going to write this one out, it's more like negative and then the 3 times the 3. So the exponent matters, even or odd, and where your parentheses are located matters, okay? Because when the negative's in parentheses, it is getting taken to that exponent. When it's not in parentheses, it is not getting taken to that exponent. And this really comes into play in tomorrow's lesson. When we're doing the order of operations, you have to have a good handle on is the sign being taken to the exponent or just the number being taken to the exponent, okay? And it's really tricky when you're looking at even powers, okay? Odd powers are a little bit easier to deal with because it doesn't really matter. The same idea applies. Here we have a -2 times a -2 times a -2. Well, you have 3 negatives, so your answer is negative. Back here, when it's not in parentheses, it's a negative, and then 2 times 2 times 2, and you still end up with a negative. So that's why these are easier. The same scenarios apply, but it doesn't really matter if you do it right or wrong if you're working with an odd exponent. All right, so again, if you need a little more time with this, go ahead and pause it. That is the beauty of working at your house remotely. You can take as much time as you needed. All right, let's jump on to some examples. So here's example 7 for today. We have a -5 squared. And notice that the negative is not in parentheses. So I am not squaring the negative, I'm only squaring the 5. So if you were going to write this one out, this would be negative and then the 5 times the 5, which is -25. Now again, if you're using that calculator, you could type this right in. Let me verify since I haven't used a calculator in 6 months. You hit the negative, then you hit the 5, and then there's an x squared button, equals, and yes, it does give you -25. Now, if you want to enter it with parentheses, let's just do a bonus problem. Let's say it looked like this. You could still type that in your calculator. You just open a set of parentheses, then the negative, then the 5, close the parentheses, then the x squared button, and it takes care of the signs for you. But we would not use a calculator for that. That's way too easy. Okay, so there's the difference. This is a bonus problem. Let's call it number 8 because we're running a little late. So let's just call that number 8, and I'm going to skip number 8. So here's 7 and 8. Pause if you need. And here's a little bonus material for today. Here are some different ways that you'll see the basic operations presented in words. So there's a few problems on your homework where you will have to see words like sum, and you'll know that we're adding. Okay? Another one is all together. That means adding. Or total is another way for addition. There's a few more, but those are the most common ones. All right, so subtract, a common way to put, to say subtract is difference. Or, and these are the tricky ones, and we'll talk about them on the next slide, less than or from. And we're gonna put a little star by those because that switches your order up. If you want 5 less than 10, you're actually starting at 10 and you're taking 5 away. So when you say less than or from and you're subtracting, you got to flip-flop the order, and we'll practice that a lot. It's kind of tricky for a lot of students. Okay, so those are the different ways to say adding and subtracting. All right, so down on multiply, the different ways that you can have multiplication in a word type problem. You'll see the word times, of course. It also might say of, or I think the most common one is usually product. So times, of, or product. I actually missed the easy one with subtraction. I'm going to jump back up. Just a simple minus, which I guess we can go all the way back. Also the simple plus, sort of the elementary ways of stating, you know, the operation is still applies here. Okay, down to divide. Divide is usually said as quotient. So the quotient of two numbers means you're going to divide. And then exponent, you can see it as to the power. Or it also might say times itself. And this is not an exclusive list. There are definitely words that we will see throughout the class, and we'll sort of have to take a minute and be like, what are they trying to say? But here are just the basic ones. So if you want to write these down, go ahead and pause, or if you want to like flip back to the slide as you're working on your homework for tonight, that is fine. But let's look at a few quick examples, and then these notes are getting a little on the longer side, so let's try to wrap it up soon. So here is number 9. So example 9 for today, the sum of a number and 12. So a number in algebra, when we don't know what that number is, I wish I could hear you all say, we use a variable. We use a variable. The most common variable is x or n. If you want to use the first letter of your first name, you can do that. However you want to do it. But pick a letter that represents an unknown number. So a number, that's going to be our x. We just talked about how sum means plus. So the sum of a number and 12 would be x plus 12. Or again, you could have something like n plus 12. All right, number 10. 12 less than triple a number. So this is kind of one of the ones where I said there would be examples that don't really fall into any of those categories that we just wrote down, but there is an operation going on. This is a good example of that. Triple a number. If you're going to triple something, you're going to multiply it by 3. So triple a number, we could write that as 3n. 12 is going to be 12. And then, this is a tricky one. Less than. I know I'm going to subtract, but order matters here. This is where I always kind of go off to the side and I think of something really, really easy. So this, I'm going to put a little thought bubble. This is Munden's thoughts right here. Okay, imagine the little circles and then I'm over there. Okay, so let's say I wanted, I used this example earlier, 5 less than 10. So if I told you I have 5 less than $10, how much money do I have? A lot of you just sort of know from the way it sounds. Well, 5 less than 10 would be the number 5. What are you actually doing there? Are you doing 5 minus 10, or are you doing 10 minus 5? What you're actually doing is 10 minus 5. So less than is one of those times where you have to switch the order. Okay, so this guy goes in the front, this guy goes in the back. So triple unnumber would be 3n, then your minus, then the 20. I think I might have said 12 earlier. Just do what the slide says, not what my voice says, especially when I mess up. All right. Let's see if we have any more examples. Yes. I'm going to go ahead and call this our final example of the day. Again, these notes are a little longer than I like. I do apologize for that. There's just a lot we need to kind of cover while we're getting these first couple days under our belt. So, quickly, the quotient of 7 and a number squared. So let's just go piece by piece. Quotient means I'm going to divide. Well, 7 is pretty easy, right? A number squared. A number squared. So that's my unknown. Squared means to the second power. So the quotient of 7 and, so that's where my division sign goes, a number squared. Okay, so that is the end of the notes for now, for today. The next thing you need to go is go to the classwork tab, right where you found this video. There should also be a worksheet. So go ahead and do that worksheet. Just like last week, if you want to copy the problems into a notebook, write it out, take a picture, submit it through Google Classroom. You can do it that way. If you have access to a printer, you can go ahead and print the worksheet out, write right on the worksheet. If you want to pull it up and do, like a screenshot and write right on it and send me a copy of that. However you want to do it, just make sure that through Google Classroom, you submit that worksheet to me. And all the homeworks this week are going to be due Friday at 4 p.m. So if I was you, I would just knock it out today. Today is Tuesday. Get it out of the way. You'll have more homework Wednesday. You'll have more homework Thursday. But if for some reason you don't quite get to it, the absolute deadline is Friday, and I am not taking any work later than Friday at 4 p.m. So again, sorry this lesson was so long. Thank you guys for bearing with me. If you have any questions, just let me know. I will be on Hangouts or email all day, and I will talk to you guys later. Bye.